Welcome to the Emory Shuttle Optimization Tool. This tool was developed by Tiffany Xu, Win Wu, Gavanta Nigabatsa, and Alan Yu. The intended purpose of the tool is to optimize the shuttle utilization and allocation given historical demand, annual budget, and the number of shuttles available. Now before you start, you will need to download and install OpenSolver, which is an Excel add-in and at risk. So here is the introduction page, and it outlines 3 simple steps that you need to take to make efficient use of the tool. The first step is entering the inputs. And to do that, simply click the icon here. So this will take you to the inputs page. Click here to get started. Now the first item that you will need to enter is the annual budget that you're allocated. So for example, you are allocated a particularly small annual budget, and it is something like $60,000. Next, you enter in the number of no service days, and this means the number of days that the shuttle system is not in service. So for example, of a whole year, 3 months, you're not in service, 190 days. And next, you enter in the cost of operating one shuttle for an hour. So this will include the salary of the driver, fuel costs, maintenance costs, etc. So let's say that comes to around $67. And next, you select the route that you want to optimize. So let's say in this case we want to look at Executive Park. Click OK. And you click this button, Shuttle Route Schedule, to see your results. Okay, so in this case, OpenSolver did not find a feasible solution because the budget was not large enough. So you click OK, and you return to enter in a larger budget. So let's say a more realistic number for Emory would be somewhere around $8.5, $8.6 million. Now you enter the number of no service days, so let's say it's 3 months, plus maybe 20 days in between for spring break and all sorts of holidays. And next you enter in the cost of operating shuttles, let's say that's around $68. And let's say now you actually want to look at the loop, and click OK. And you see shuttle route schedule. So here you see that Solver actually found a solution and that it is optimized, and click OK. And it will take you to this page. Now this page will tell you 3 important pieces of information. The first is the number of shuttles that you should allocate in any given time period. So for example, between 8 and 9, you should have 2 shuttles running at any given for this hour. Between 9 and 10, you should have 3. Between 10 and 11, you should have 4, and so on. And as you can see, this is actually based on demand. So this is the forecasted demand based on historical demand using exponential smoothing. And as you can see, as demand increases, the number of shuttles also increase. And the final column here is the interval time. This tells you how often a shuttle leaves. So in this particular case, between 7 to 8, a shuttle should leave every 30 minutes. From 8 to 9, it should leave every 15 minutes. 9 to 10, every 12 minutes, etc. And this no service at the bottom simply means that there is no demand and therefore no shuttles should be running. At the bottom, you're given the total daily cost of running the entire shuttle system. And on the right here, demand is graphed against time to let you visualize during which time periods of the day is demand the highest. So after you've taken in all the information, you can click the button here, Return, and it will take you back to the inputs page. So say now you want to look at all of the routes. There's a button here that conveniently takes you to all of the routes and the route schedules. So here's demand plotted. Here's the number of shuttles you'd have for each given route at any given time based on the inputs that you have entered. And here's the interval time. So after you've taken in all this information, click Return. Now, this button also lets you reset your inputs. But let's say you want to look at the utilization of each shuttle and the capacity and how you can improve the efficiency. You click this button called Risk Analysis. And by doing that, the at-risk software will run. and it will take you to this page. So this page will tell you a couple of things. First of all, we have data on the left. Let's close this first. We have data on the left, and this is 1 year worth of data that we collected from the Emory Transportation Services. And as you can see, the day of the week here and the total riders. And the reason why we do not have weekends, as you can see, is because all of the shuttle routes that we are optimizing are on-campus routes, and they do not run in the weekend. So day of the week, you can see here the total riders on any of these given days and the utilization rate. Here you can also see the total capacity per day, the total riders served, and the optimal number of shuttles that you should have on any given day. And also here demand, which we found to be normally distributed. But let's look at what ARISC said. So if you go to ARISC and click Browse Results, here you can actually find out, what is the percentage, what is the chance that the shuttle will be overutilized. So here you can just type in 1 for 100%, and you'll find that there's a 43.5% chance that the loop will be overutilized. And this is very useful information to you because now you know you need to allocate more budget or more shuttles to your system and to this route if you want to improve the efficiency. And on the right here is again demand plotted. And after you've taken in all the information, you can click return and go back to this page. And that pretty much summarizes the very useful tool that we have created here. But we also want to show you our model here. So named Shuttle Optimization Model is the model that we've built with all our variables and constraints. The ARISC setup here, and also the demand forecast using exponential smoothing. So that concludes the demonstration of the tool, and we hope you've enjoyed it. And we definitely hope that you can make good use of this and ultimately optimize and improve your shuttle system. Thank you for watching.